I'm doing question number 4 for a 2019 AP Calculus BC free response question. For A, it says find the rate of change of volume of the water in the barrier with respect to time when the height of the water is 4 feet, indicate units of measure. So we have the graph here. We have a diameter of 2, so radius is equal to 1. And we're doing respect to time, so we have A equals to dV over dt. Okay, first of all, we know the volume is V equals to pi r squared h. Then dV over dt equal to pi r squared h times dh dt. And h is 1, so dh dt. And after we plug in the answers, it's about negative pi over 5 with the unit feet cube per second. For question B, it says when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So for this question, we will have to take a second derivative, which we already have the first derivative here. So dh dt squared is equals to negative 1/10 square root of h times the dh over dt, which is negative 1 over 20 h to the negative 1/2 times negative 1/10 times square root of h, which evaluate at h equals 3. And that gives us approximately 1 over 200 feet per second squared. Since the second derivative, since the dt squared is greater than 0, then we know that dh dt is increasing at time at height h equals to 3, and the second derivative is positive. For C, it says at t equals 0 and the height of water is 5, use the separation of variables. So we know that dh dt is equal to negative 1/10 square root of h. And we do the separation variable, that will be h to the negative 1/2 dh equals to negative 1/10 dt. Then we can do the integral on both sides, which is negative 1/10 dt. And after we take the antiderivative, we have 2h1/2 equals to negative 1/10 t plus c. Since the initial value are t equals 0, h equals to 5, so we plug in here, and we have 0 here, that's 0, and h is 5, so it would just be 2, 5, 1/2, which is c is equal to 2 square root of 5. Then we plug in c, then we have ht equals to 1 over 400 t squared plus 2 square root of 5. Thank you.